Hello, welcome back. Today we're going to be talking about something called transformations. By the end of this video, you should be able to identify a function by its equation, graph the parent function, and then move the parent function up or down, which is something called a transformation. So I have two vocabulary words for this video, the first of which is a parent function. Parent function is the most basic form of a function. At least that's the definition we're going to use for the purposes of this video. Let's go ahead and meet the parents. First parent function, f of x equals x. That is the most simple form of a linear parent function. If you have not done so, go ahead and fill out this table. Notice I've changed the f of x to y, so those can be interchanged. And go ahead and fill out the y values and then graph them. Alright, having them graphed, again y, we're making y the same thing as f of x, so that we can go ahead and graph it on our xy graph. If we graph those points, notice it makes a straight line if we connect the dots. That's why we call this a linear function, because when you connect the dots for the equation, it makes a line. Our next parent function is the quadratic parent function. F of x equals x squared. Again, I'm going to say that f of x is equal to y, so I can graph it on my xy axis. Go ahead and fill out the table and graph the function, and press play when you're ready to see the answer. Okay, we went ahead and filled out the table. If x is -2, -2 times -2, or -2 squared is +4, and so on. When we graphed it, it gave us this shape right here. And this shape, when we connect the dots, is called a parabola. It makes kind of a U shape, not really V, not really U, but kind of U shape. And again, we call the shape of our quadratic parent function a parabola. The next one is the exponential parent function. Again, fill out the table and graph it, and press play when you're ready to see the answer. The work for this one's a little bit more involved, so I'm going to go ahead and show you if you have not gotten it already. If x is -2, what would f of x or y be? It would be 2 to the -2. Remember, you can't have negative exponents. To make that negative exponent positive, you would have to take the reciprocal. So it becomes 1 over 2 to the +2. 1 over 2 to the +2 is 1 over 4. If x is -1, f of x would be 1/2. 0, anything to the 0 power is 1. 2 to the 1 is 2. 2 to the 2 is 4. Graphing those points, we get -2 and 1/4 of the way between 0 and 1. Get as close as you can. Okay, -1 would be 1/2, so we go half of the way. 0, 1, 1, 2, and 2, 4. If we kept on going, 2 to the 3rd would be 8, so 3, 8. 2 to the -3rd would be -1/8, which is even close to the axis. And you should start seeing a pattern. From left to right, it starts increasing very quickly. Also, we're not really going to take a lot of time to talk about this, but it never actually touches the x-axis. Again, this will be saved for a later lesson. All I want you to do right now is to know that it makes this shape right here, and this is your exponential parent function. We're now into that last objective, and in order to help us better understand it, I've asked the following question. What happens if you add a number to the parent function? Let's find out. Suppose f of x is equal to x squared plus 2. What we've done is we've taken the parent quadratic function, x squared, and we've added 2 to x squared. Let's go ahead and fill out the table for our parent before we add the 2. 4, 1, 0, 1, and 4. We did that previously. Now what happens if you just add the 2? If you add 2 to x squared, you just add 2 to all the x squared values, giving us 6, 3, 2, 3, and 6. Because 4 plus 2 is 6, 1 plus 2 is 3, 0 plus 2 is 2, and so on. I'm going to graph both of these so you can see what happens to the function when you add 2 to the outside. You can go and graph it on your own if you'd like, and press play when you're ready to see the answer. What happened to your dots as you went from the red to the blue? Well, from the red to the blue, all of your dots went up 2. Notice we can go from every red to every blue dot by going up 2. So to answer our question, we can draw our new function, x squared plus 2. What happens to the parent function when you add a number to it? The answer is that you move the parent function up. Or you can say shift or move the parent function up. So if adding a number causes the function to shift up, what do you suppose would happen when you subtracted a number from the parent function? Go ahead and fill out the table, graph both functions, and see what happened to x squared when you subtract 6. Okay, I've gone ahead and drawn the dots for you, the red being the parent function, our parent quadratic, the blue being the transformed or the moved functions. And if you notice, from the red to the blue, all of the points were shifted down 6. So adding a number causes the points to be shifted down, or sorry, up, and subtracting a number causes the points to be shifted down. So what happens? You shift the function down. By how much? Well, you shift it down this number of units, whatever this one is. So in this case, we shifted it down 6 units since we subtracted 6 from the function. This brings us to our beginning definition of the word transformations. When you transform or change a parent function, the word transform meaning change, you change the function's position on a graph by adding or subtracting a constant. Notice this says beginning definition. As we get further into the course, we'll extend this definition a little bit more to involve other ways of changing the graph. Again, for right now, all we're doing is changing the graph's position by adding or subtracting a constant. Now we're on to an actual example of what you will be required to do. Name the parent function for the following, then write the transformation, then graph the function. Let's go ahead and write the name. Notice it says f of x is 2 to the x plus 5. 2 to the x is the parent function, so its parent is an exponential. The reason we call this an exponential function is because we have a variable x in the exponent. The transformation, well, since there's a plus 5 outside of our 2 to the x, our transformation is going to be shift our parent function up 5 units. To save time in the future, you may go ahead and write 5 up arrow to let me know that you've shifted the graph up 5 units. Once you've done this, notice it says graph the function. That means graph the transformed function. What I'd like you to do is go ahead and graph the parent and then shift the parent up 5. Let me show you what I mean. negative 2 1/4. Again, this table corresponds to our parent function we've already done. Negative 1 1/2, 0 1, 1 2, and 2 4. And what we're going to do with these points is we're going to shift them up 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Shifting them up 5, and so on. And then I'd like you to connect the dots on your transformed function. Notice, when we go ahead and graph our transformed function, we do not have to fill out a separate table for the transformation. We can just look back at our parent function and shift it up or down corresponding to the plus or minus number at the end. We'll go ahead and try this one. I went ahead and graphed the points for you of our parent function. The parent function, since it's just x and then minus 5, is a linear parent function because it's going to create a straight line. And the transformation, since it's a minus 5, is we're going to be moving 5 down. So in order to graph the function, all we've got to do is take all of our points and move them down 5 units. And there you go. Once we've connected our dots, you have named, graphed, and transformed a parent function.